Hello and welcome back to Concept Bio, where in my previous video I had discussed about the differentiation formulas. I'll give a link for the video in the description below on the iCard, where I'd gone over the differential formulas and I had told about the L'Hopital rule along with some practice questions for those. Now in this video I'm going to be going over the product rule. What is the product rule? Product rule is nothing but suppose we have some term u and some term v. Suppose it's sine, sometimes it's cos, anything. Okay, something is u, something is v. And we have to take a differentiation of it. What can we do? What we should do is there is something known as the product rule, wherein we do the differentiation of this will be nothing but v du by dx or du by d whatever plus u dv by dx. So we have to split this into like this. First take the differential of u where keeping v constant, and then we'll take the differentiation of v keeping u constant. So this can also be written as v u dash plus u v dash. Okay, dash, this prime meaning you're taking the differential of it. I'll explain this in my previous video. So this is what basically it means. Now to make it simpler so that you can understand it later on, I will say it is, this is the best way to write it. Sometimes people will also write it as uv dash plus vu dash. Both are interchangeable. It is best to remember it where we keep vu dash plus uv dash because it's simple to remember the differential formula, division rule, which I'll be talking about next. Okay, so I'll just first explain this with a few practice equations. Suppose I have d by dx of x square times ln x. So what will be the value over here? We have to take v, that is, this is v, this is u. Alright, first you have to take which is v and which is u, and then you have to take v u dash plus u v dash. So what does that mean? I have to do v is constant, that is ln x, into differential of x square, d by dx of x square, plus I have to take u just like this, x square times d by dx of ln x. Okay, so now if you remember from my previous video, what is ln x will just stay the same. What is the d by dx of x square? We know that x to the power x to the power n minus 1. So what would that be? 2x to the power 2 minus 1, which is 1. Alright, plus x square remains the same. What is the differential of ln x? From my previous video, you know it's 1 by x. So 1 by x. So what will this be equal to? This will be equal to 2x ln x plus x square by x. We can simplify this as 2x ln x plus x, because x and x, one x will get cancelled out. Alright, so this is the product rule. Suppose if the question was asked d by dx of x square plus ln x, then in this case we can just split these terms as d by dx of x square plus d by dx of ln x, which will be nothing but 2x plus 1 by x. Alright, so but the question asks us a product, that's why we use the product rule. Again, we'll just do with one more question, sin x into cos x, differential of sin x into cos x. So I'll make this u, I'll make this v. Okay, first I'll keep v common, I'll do u dash plus u v dash. Alright, so what will that be? This will be equal to, what is v? Cos x. Cos x into d by dx of sin x plus what is u? Sin x I'll keep common into d by dx of cos x. Alright, so what will that be equal to? Cos x into what is the differential of sin x? In my previous video I had told it is just cos x. So cos x into cos x plus sin x. What is the differentiation of cos x? It is minus sin x. Alright, remember this. And then so what will this be equal to? Cos square x plus cos square x minus sin square x, because the sign positive minus, when it comes it will become minus in total. And this is a final answer. Suppose if I had just told d by dx, suppose if the question was d by dx of sin x plus cos x, then directly the answer would just be equal to cos x minus sin x. Why? Because if it's addition, we can split up the terms and we can do the differential. But if it's a product rule, we have to use the product rule, that is vu dash plus uv dash. Alright. So now next, I'll be going on into something known as the division rule. Just before that, I'll just see if my recording is coming out well, if everything is in frame. Okay, super. So now there is something known as division rule. Suppose now the terms are u by v. Okay, not uv but u by v. Then what we have to do is, this is a bit complicated, but I'm pretty sure everyone will be able to learn. It is v u dash minus u v dash divided by v square. Alright, this is why I told you to remember the product rule as such. Vu dash plus u. Some people just give it as uv dash plus vu dash, but if you remember it as u becoming differentiated first, we can use the same thing for division. See, first u will get differentiation and then v will get differentiated. Okay, so if you keep this simple tricks, it will be easier to remember it. Alright, in this, because it's addition, it doesn't matter which way you write it. You can write it in both ways. But since this is a minus term, you have to make this order correct. So it's v u dash minus u v dash by v square. Alright, so next. So, oh, did I not make any practice questions for that? Okay, I'll just make some random practice question. Suppose we'll take the term d by dx of, let's say, x square by 3x. First we'll do a simple one. Alright. So what will this will be my u term, this will be my v term. What is v? So I'll be doing v, so this formula when I apply, it will be 3x into u dash. What is, I'll just write it as d by dx of x square minus u, keeping u constant, x square constant, and then d by dx of 3x, the whole divided by v square, that is 3x square, 3x the whole square, sorry. Okay, so now what will this can be written down as 3x into d by dx of x square is nothing but 2x. Okay, minus x square into d by dx of 3x is nothing but 3. Why? Because I've already explained my previous the formulas, divided by 9x square, or 3x to the power 2 is same. So then what can this be simplified as? This can be written as 6x square minus 3x square divided by 9x square. So this can again be simplified as 3x minus 3 is again 3x square divided by 9x square. So this can be again simplified as 1 by 3, because x cancels, this is once, this is thrice, 1 by 3, and this is the final answer. So you can keep simplifying like this, and this is what you have to do in differential. V u dash minus u v dash by v square. Please remember this is the term. Okay, first u will get differentiated, then v will get differentiated. Now I'll be going into something known as composite rule. Composite rule is a very tricky, if you know the concept it's simple, but if you don't know, it looks very complicated and very daunting. So I'll just tell. Composite meaning you have some term, suppose you have sine. We all know differential of sine x, but sometimes people ask like sine x square, instead of x being normal, it is x square. So what do we do in such cases? In such cases, what we do is we treat it as original value itself. We'll treat sine x square to be as if it is sine x only. Okay, so what is the difference? So this will be nothing but we just assume it is differential of sine x. What is the differentiation of cos x? It is cos x. But don't keep this variable like this, keep it as the original variable that people have asked. So cos x square. Now you have to multiply into, now you have to take the differential of this inner part. So what is the differential of the inner part? D by dx of x square is nothing but 2x. So this is the final answer. Differential of sine x square is nothing but 2x cos x square. So what does this basically mean? It's like an onion. Okay, you have different layers in the onion. The first layer is nothing but your sine x. You'll just assume it. Then okay, you differentiate it, that term goes off. Then this differential moves and attacks this inside part. So what is the differential of x square? And that's how you do it. So this is the composite part of it. Alright, so I'll ask another question. Suppose if I say d by, okay, I'll just do this and then I'll come back to some other. If we have more time, we'll go into more questions. D by dx of ln x cube. We know the difference d by dx of ln x is nothing but 1 by x. But what is this ln x cube? Why is this extra part? This is the composite that's occurring. So first assume it is just ln x only they have written. So d by dx of ln x is 1 by x. But it's actually x cube that you written. So x cube you write. Alright. Into, now this d by dx will attack the inside part. What is this x cube inside? D by dx of x to the power 3 is 3x square. And simple. So this final form is 3x square divided by x cube. If you want, you can cancel this thing and this will become 1. So this will hold, so it will become 3 by x. Alright, and again we can do d by dx of ex square. What does this resemble? It looks like d by dx of e power x. What is differential of e power x? It is e power x itself. Okay, and multiply. Now this will attack this top part because this is the addition that people are, the modification. So the modification you have to also differentiate. So what happens? D by dx of x square is nothing but 2x. So what is the answer equal to? 2x e power x square. Okay, if you want to, I have time. Yeah, I have time. I'll just do a few more questions. Suppose if I have d by dx of, let's say, from my questions, I'll just take cos x, cos of, let's see, cos of ln x. This will never happen. I'm just making, I'm taking a very extreme condition so that you'll understand what it means. Okay, so what is d by dx of cos of ln x? So what we'll do here is, first we will take d by dx of cos x. What is, we know the differential of cos is nothing but minus sine of ln x into, what is the differential of ln x? 1 by x. So this will completely be equal to minus sine of ln x divided by x. Okay, this is a very extreme term, but this is what you can understand. First you have to treat it like layers of an onion. First you differentiate the outer layer, then you differentiate the inner layer, and this can keep going on, and this is what's usually done. So these are the composite terms that come in differentiation. I hope with the previous video and this current video, you are able to understand and have a grasp of what differentiation actually is from the basics. And usually for GATE exam level, this is the kind of level questions that they're generally asked. And if required, you can give it in the comment section down below. I can continue the series where I can give more practice questions, where I'll be solving more practice questions for differentiation. And if required, I'll be even going into matrices which are commonly asked in many competitive exams, both here in India and abroad. So I hope you enjoyed this brief series on mathematics, and I'll see you guys in the next video. Thank you for watching. Bye.